Hello there, I'm Jimmy Vegas. This is how to create a 3D endless runner in Unity, and welcome to episode 3. In this tutorial, we are going to use some C# coding to make our player move forward. Don't forget, click the subscribe button and click on the bell icon as well to stay up to date with every tutorial still to come in this series and everything else on game development on my channel. With that in mind, let's get to work. So, up until now, we have some objects in place, and we also have a running place for us to go. We have a camera and we have our player. So firstly, let's rename this cube that we created, and let's just call this player. Now, we need a specific place to store all of our scripts so things don't get too messy. So let's go to Assets, let's right click, Create, Folder, and let's call this one Scripts. And let's go in here and let's create another folder inside here to make sure we keep things neat and tidy. This one is going to be player. So in here, anything relating to the player, any script that relates to movement or interaction or anything like that will be inside this folder. And let's right click, create C# script. Now, it is important what we name our C# script, and it will become apparent why that is the case later on in this tutorial. I'm going to call this one player move with a capital P and a capital M. So once we have the name in place, double click and it will begin to open in Visual Studio. Now, Visual Studio is the application that we're going to be doing all the programming in, and you can do it in any application. It's entirely up to you. As long as you can edit scripts, it's fine. Visual Studio does come bundled with Unity, so if you want to use it, you can, and it doesn't matter what version of Visual Studio you use, the script and code is going to be the same. So, for those of you who have never coded before and never seen this before, this is just basically a default standard script. Whenever you create a new one, it gives you these lines of code. Now you will notice here that the public class player move is the same as our script. These two have to be identical. If the script name changes, you have to also change the public class name. If the class name changes, you have to change the original script name. So just make sure both of those exist. So there are many lines of code here which seem confusing to some people. Like I say, for new people to coding, they may not fully understand. So let's go through this and explain what each bit does. So at the top, we have something called namespace. A namespace is a way of the script recognizing where information can come from. So as a good example, let's say if we are using some UI, which is some imagery on screen, we would need to add in a namespace for UI. We're not going to do that in this tutorial, but we will later on because it is going to be vital in different scripts. But this particular script doesn't need anything else adding to the namespace. It already recognizes everything it needs inside this section using Unity Engine. So we're all good on that front. But if we do need to add a namespace, it would go here in the top section. Next, we have public class player move mono behavior. This is a way of defining where the script technically begins for its execution. So in this case, we need to do most of our work inside this class. And the class is where everything is contained. What is contained in there? Things like methods, things like coroutines, things like variables. What are those three? Well, they are different sections that you have inside that class. Remember, everything we do here is going to be inside this class. So for example, here we have void start. What is void start? Void start is a method, and something like start will occur once. So the difference between void start and void update is here in this green section. What is this green section? These are known as annotations. An annotation is a way of blocking out a certain section of a script which is just for information purposes. These green lines will never be executed via code. If we were to get rid of these two slashes at the front, it would confuse the script. As we can see, we now have some underlines there. And if I save that script as it is, because this is not a line of code, this is just some words, the script doesn't recognize it. And if we go back into Unity, you will see down here we have a section that says basically I'm confused. And do you remember in the first tutorial when I spoke about the console? This is where you will see there are errors. So it's telling us a couple of different things. It's telling us there's an invalid token in class. It's also saying it's expecting a semicolon, which it is, which I will get around to in just a moment. So that realistically needs to either be annotated out or deleted. So void start is called just once when the script loads. Void update is called every single frame. So it's constantly monitoring a situation or constantly doing something. That's how you can think of void update working. So what do we actually want this script to do? We want this script to be able to move our player forward at all times. It's an endless runner. So we need to firstly declare a variable. And that variable is going to be the move speed, i.e. how fast we want something to move. So to declare a variable like this, we need to go here below where it says public class, and we need to type the word public, because this is going to be a public variable that we want to be able to see in our inspector panel. If we don't type the word public, we would not see this in our inspector panel, but for all intents and purposes, we want to be able to see it. So we say public, and then we declare the type of variable. Now it can either be an integer, which is a whole number, or a float, which is a decimal number. It's got to be either one of those two, and it's entirely up to you which one you want to use. I would prefer to use float. The reason I want to use float is because I need this to be a decimal number at some point. So later on in development, when we speed up how fast the player is going, we want to be able to go incremental in stages. So we need it to be a decimal number. So we need it to be a float. So type the word float, and you'll notice that I have not used any capitalization here either. So public and float are both low caps on the first letter. Capitalization is very, very important when it comes to programming. The difference between, for example, a game object, a lowercase g and an uppercase g, they are two different things when it comes to programming in C#. So just keep that in mind, that capitalization is important. So after we've said the type of variable, we now need to say what it's called. And this is where you can call it anything at all, as long as it is all one word. So for example, I want this to be move speed. I can't call this move space speed. It has to be all one. And I've used something called camel casing here. That means that the first letter of the first word is lowercase. The subsequent letters of every subsequent word is uppercase. So if this was called move speed speed, the next one would also be uppercase. If it was just called speeding, for example, I would just call it speeding, just with a lowercase s, and that would be it. So let's call this, like I say, move speed. And we also want to give it a value. We don't have to, but we want to at this point. So if we weren't giving it a value, we would just press semicolon, and that would end that line of code. So when it comes to coding, every line of code, at least in this sense, will end with either a curly bracket, much like we have here, 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 or here, a semicolon, or depending on your coding style, either an underline or some brackets, parentheses. Either way, going back to what I was saying, we need to set this as a value. So rather than have a semicolon right now, we're going to have equals and 3. So that means that this value called move speed is going to be equal to 3. And then we have our semicolon. Now, as this is going to be a movement script, so something is going to be moving constantly, we don't want it to update just once. We want it to update every single frame. So that means we can't do this inside the start method. So we can delete that and get rid of a couple of lines of code that aren't necessary. It may not seem a lot, but if you get rid of a couple of lines in every single script in a massive game, you can save a lot of space and a lot of resources. So try and keep everything as compact as possible, but also as legible as possible so you can read it properly. So what do we do inside void update to have something moving constantly? Well, it all comes back to this section in Unity. So if we go back into Unity and click on the player, transform. So remember this position here, if we were to constantly move that, our player would be technically moving. So we want to undo that. So we want to play around with this section and get a script that automatically changes this value for us. So if we head back into Unity, we can say transform dot translate, and that is a capital T. So what this is doing is it is basically translating a number constantly. So the word translate here doesn't mean the same as, for example, translating a foreign language. It means translating something as in changing. So in this case, we need to put some brackets. Now, inside these brackets, we now need to tell it what direction to go. Now, the best way of explaining this is on the Z or Z axis, that is always known as forwards. So if you want to move something forwards, you would use vector3.forward. If you want to move something backwards, you could still technically use forwards and just have a negative value. But we're not doing that, we're moving it forwards. So because this is a 3D environment, we do need to use vector3. So it's vector3.forward. Now, this is not going to do anything in its current state. The reason being is we need to tell it how fast to move forward. So every frame, how fast do we want this to move forward? Everything we do needs to be done in the game's time. And what I mean by that is we can't just have this as 3. It needs to be relative to the time and world around it. So there are a couple of different things that we need to place in to get this working. So we need to multiply the forward velocity, technically, by the delta time. So time with a capital T dot delta time. And what this is going to do is it is going to move things forward relative to the time that the game is running at. If the game time was set to 0, i.e. paused, then nothing would happen because anything multiplied by 0 is 0, which means no movement would occur. So as long as the game time is set to 1, which it probably always will be unless it's paused, then this will run just fine. We now need to tell it how fast. So we need to give it a multiplier, which in this case is going to be the move speed. So move speed. Final thing we have to do is comma and tell it what all this movement is relative to, i.e. the world around it. So we need to make this movement relative to the world we're creating. So in this case, space with a capital S dot world. Close bracket, semicolon, and save the script. So you can either hold Control, press S, or go File and Save. So it's a very simple script, and I realise that this tutorial has gone on for, it's over 10 minutes now, I think. But either way, I think it gives a really, really good introduction to how coding works, how we can manipulate it, and everything around it. So next thing we need to do is basically go back into Unity and test this. But just so as we understand what's going on exactly, let's spend 30 seconds going over what we've done here. We have a new script and call it player move. We have the class called that as well. We've told it this is how fast we want it to move. And then we've also told it down here, this is how I want you to move relative to the world around you. So if we head back into Unity now, these errors should disappear because we have got rid of the errors. And if you do have any problems, I will put the script on my website. Head over there, Downloads and Assets, Endless Runner, tutorial number 3, and you can download that script I've just written for free. And all we need to do is apply this player move script onto our player. So drag and drop. And there we have the move speed. Now, do you remember earlier when I said we need to have the word public so we can see it inside the inspector panel? This is why. So I always like to be able to see the variables in the inspector panel, for mainly for debug purposes, just to know things are working correctly. But you don't necessarily have to. But again, it's down to your own coding style. Now, if we press play and go into the game view for the very first time, we won't see a whole lot. All we should see is this cube moving away from us. So this cube will look like it's just going away because the camera isn't going to move, but this cube will move because we have told it to now. The script is attached. So if we press the play button, it'll go into the game view, and there we go. We can see it moving. And if I go into the scene view and just pan around, we can see, yep, it's moving. Now that will move endlessly. It won't stop. It won't fall. There are no physics in this game right now, so it won't just fall off a cliff. Again, that's something that we can deal with. We can also change this real time as well. So if we put that as 8, you should see it has moved quicker. And do you remember earlier when I said that we could technically use forwards to mean backwards if it was a negative? Well, if we put that as negative 20, you can see it moving back towards us. So although the script still says forward, we're moving it backwards by using a negative. So let's put that back to 3. And you can see that's still moving. Perfect. So this is why I wanted to have a decimal, because I want it to be able to kind of increase, obviously not that fast, but it gets faster and faster to make the game more and more difficult. So next tutorial, we're going to carry on with some programming, and we are going to make our player move from side to side, because at the moment we have no control over this player. So basically we're going to add some controls to this player and prevent it from going any further to one side or the other, because we don't want it to end up falling off. We need to have limits. So that is all coming up in the next tutorial. Until then, guys, thank you very much for watching.